Hi, I'm Max Harwell, Senior Field Service Engineer at Honeywell. Today we're going to talk about upgrading your existing meters electronics from the Series 3, Series 4 generation electronics to the Series 6 upgrade kit or the retrofit kit. Why would we want to do that, first of all? Well, we'd like to do that because the existing hardware doesn't support Ethernet connectivity. The new Series 6 upgrade kit does, which allows us to get into using the Sonic Explorer software package that was designed specifically for this electronics package, as well as being able to connect the new electronics into your company's own network. Before we get started, I just wanted to touch on very briefly that we need to always remember to wear our personal protective equipment, follow our company's safety procedures with regards to permits, lockout, tagouts, that sort of thing. Another consideration is that while we'll be working on the meter, the ideal situation would be to depressurize the meter, but obviously we can't always do that. So we're going to talk about this in terms of leaving the meter pressurized up. Obviously we're doing this in a lab environment here. There's no pressure on this meter. There's no energy on this meter, in fact. But if you can't depressurize the meter, what you would like to do is try to make it as safe as possible in terms of maybe removing any pressure, tubing connections, that sort of thing. Before we get started, before we can even really open up this explosion-proof box that we've already removed the bolts on here, in the real world, in the field, you're going to need to de-energize all the circuits that come into and go out of this box so that we make this safe for you to work on. So once you've done that, then we would open this box up. Again, we've removed the bolts here so that we can take this lid out of our way. We're going to first be removing all of the electronics that are in the box now, okay? This particular one is built with a Series 4. The Series 3 is very similar to this. We have a frequency controller card or an FCC02 card, the previous generation, mounted on the side of the box here. We have some terminal blocks here where you make your input and output connections that are laid down on a DIN rail, okay? We're basically going to take every single thing out of this box with the exception of the DIN rail itself is the only thing that's going to remain. On the transducer cabling, we have to do some modifications to the transducer cabling as we go along. We're going to also build the new system up. I've got a separate box over here that's not mounted on a meter. I'm going to show you how we're going to do that. Okay, so let's get started. Put my personal protective equipment on. First thing we would do is we're going to disconnect the transducer cables. I think I touched on this, but just to reiterate, before we start working on the meter, you need to make your gas control or measurement people aware of the fact that you're going to be without measurement on this device for a period of probably 1 to 2 hours. Disconnect the transducer cables. All these things plug in. While we're at it, I'm looking at a terminal block here that doesn't have any wiring in it, but of course your meter in the field has your wiring coming into the box here as well as going out. So before starting this, really, you need to de-energize all the circuits as I mentioned previously, but also when you determinate these wires, meaning loosen up the screws in the terminal blocks here and remove these wires, you need to mark those wires so that you know how to land them again after we've installed the new upgrade kit. And they need to be marked for identification. They also need to be taped. Even though they've been de-energized, we don't want anything shorting against an earth ground that could create a problem there. So just for safety's sake, we want to tape those wires off. I'm going to loosen up the screws in the corners of this. I've already done this. Loosen the 4 screws up in the corners that hold the sub panel or the back plate into the J box. It's going to be a little bit trickier in your box because you've got field wiring coming in the bottom of the box here, which I don't have. I have some ground wires here, which I can unplug. I can set this aside. We're not going to reuse any of that. The ground wire actually we'll remove from the box. We won't be reusing that either. We have this frequency controller, F3. This is an FC3 card over here. I'm going to remove the screws that hold the bracket into the box. May be necessary to take the card off of the bracket first to be able to reach both of the screws. And we're going to just unplug all of these wires. I'm going to set that aside. Again, we're not reusing any of that equipment. Typically, these boxes have a lot of tie wrap mounts and wire ties, cable ties, where the wires have been tied into the box to make them neat and keep them out of the way. You can cut any of those tie wraps loose that you need to remove the wiring harness. Next, we're just going to take a large screwdriver and we're just going to pop these terminal blocks loose from the DIN rail. Again, you don't have to worry too much about keeping these in order or anything like that. If the numbering strips get popped off, you can just basically discard all of that. On the power side, we have one block here. The green and yellow is the earth ground block. That is the one terminal block that's actually screwed down into the rail. So you need to loosen up the center screw on that so that we can get that block out of the box. Normally the box has some screws here. This is a Q.sonic 3 box, a 3-path meter. A Q.sonic 5 box for a 5-path meter is the same width but rectangular, so it's a little bit longer. That box has 3 holes on this side with a tie wrap mount here that was put in there so you could tie down your wiring. We're going to remove those screws. We're going to have some different kind of hardware that goes in there on the new box. Okay, so we're down to just the DIN rail. The separator blocks can remain on the DIN rail. We may loosen those up to facilitate installation of the new one. Notice that we still have all the transducer cables in here. Next step would be to loosen the screws on these 2-pin Phoenix connectors of the transducers all the way around. Just going to show you one for illustration's sake. We need to loosen up the cable glands so that we can pull these cables back out of the box. What we're going to do with these transducer cables, the current system uses a 2-wire excitation and signal processing method. There's actually 3 wires inside this cable. There's 2 wires and a shield. What we've done is on the current system, we've taken the shield and connected it to the low side wire. We're going to cut the ferrule right off on the side that has the shield and the negative wire connected. My gloves back on. I've got some shrink tubing on that. I just cut that back slightly. Some wire cutters. Can pull that shrink tubing off of there. Where I've cut the ferrule off, that should actually break the connection between the white wire and the shield wire. I'm now going to strip the white wire back just a little so that I can crimp a ferrule onto it. I'll follow the same procedure on the shield wire. I'm going to slip a piece of shrink tubing down over the shield wire to protect the bare wire from shorting out. I use a larger ferrule on the shield wire because the diameter of that wire is larger. I'm going to crimp that ferrule on. I need to repeat that procedure for all of the 6 transducer cables, or in the case of a Q.sonic 5, the 10 transducer cables. Once we've completed the adaptation of all the transducer cables, we can leave those cables outside the box for the moment we'll move over to the other workstation here to show you the reassembly into the box of the upgrade kit, followed by the final step, which will be to terminate these transducer cables after they've been passed through the cable glands into the explosion-proof box using the new 3-pin Phoenix connectors. The details about how to connect those are in the manual, as well as the entire assembly procedure. So, having completed the disassembly of the older equipment from our junction box, our outlet box on our meter, I want to move on to the assembly of the new equipment, the Series 6 upgrade kit, into that same outlet box. For convenience, we've taken a box that's not mounted on a meter, so it's easier for me to work on here. And just to establish our orientation, I'm looking at the box. The top is here. Transducer cables come in the left and the right. The customer's wiring comes in from the bottom side over here where I'm standing. The DIN rail inside here is at the head of the box right here. Okay. So the first thing I'm going to do is identify my barrel or ferrule type studs and screws that I'm going to install in the side walls of the box here. There's 4 of these. So there are 2 on the left-hand side that are going to support the frequency controller card, which is already mounted on a bracket here with these special clips riveted to it. And I have 2 others on the right-hand side of the box over here, which are going to support the field terminal board, which is mounted already on a bracket with those same type of clips. There's a cover plate on here, which we'll have to remove when we want to wire the field terminal board up. Now, the new electronics module, the card cage here with the cards pre-installed on it, transducer adapter boards and so forth, is mounted on a square plate, which is designed to fit this Q.sonic 3 box. If we have the Q.sonic 5 meter, which has the larger rectangular box, the square plate is installed on the rectangular plate as it arrives to you. If you're going to install this plate into the larger box, you would put the entire assembly in there. To mount just the top plate into the smaller square box, we're going to unscrew this plate, which I've already pre-loosened these, from the larger plate to separate those. So that I can, if I don't need the larger plate for the Q5 box, I can set that aside or discard that. I'm going to set the square plate oriented in this direction down into the box at this point, which is virtually empty, having only the DIN rail and the terminal block separators in here, plus the studs which we have installed. I'm going to pull the plate as far towards the back end where I'm standing here as possible to allow some room to install the terminal blocks. At this point, we're not going to tighten those screws back into the bottom of the outlet box just yet. Okay, we want that panel to be loose to help us facilitate the installation of this wiring harness. So there's some details in the manual here, but basically these terminal blocks come in a few separate pieces, which are tie wrapped together to keep them put together. We're going to hook those by the top rail and snap them into the bottom rail. On the green and yellow ground block, we have 1 screw which has to be tightened to mechanically attach this. That was the terminal block 1. I'm going to start with the terminal block 2, 1 through 8 section. Again, I'm going to cut the tie wrap. Snap those terminal blocks into the DIN rail by hooking them on the top. Snap those in. Next section is the 9 through 16 TB2 blocks. Same procedure. We're going to get the wires down through the gap there. Snap those in place, and finally, it's the 17 through 22. Snap those in place. I can slide my right-hand separator block over till it's snug against the number 22 block. Just tighten that down. At this point, I'm tucking some wires underneath the connector of the wiring harness that goes from the backplane board over to the field terminal board. So I'm laying these in place for the field terminal board, which is going to be on the right side over here. These Phoenix connectors and these other Phoenix connectors are associated with the frequency control card, which is on the left side of the box here. At this point, I can center the back plate, tighten the 4 screws in the corners. At this point, I'm ready to bring my transducer cables back through the cable glands on the side of the box, on your field wired box. Once I bring the transducer cable through each gland, I can terminate those cables into a 3-pin Phoenix connector from the new kit and connect the 3-pin Phoenix connectors to the transducer adapter boards on the left and right sides of the card cage inside here. At this point, I can connect the Phoenix connectors to my FC3 board. May help at this point to tie wrap these cables together. Just to keep those together. I'm going to install the FC3 bracket by raising these clips up, pushing the bracket down firmly against the left side wall of the Adlat box and snapping the clips down. At this point, I'm going to disconnect this cable harness from the back plane that's already mounted in the box, just to make it easier to get these connectors correctly terminated here. The smaller one's a little bit difficult because it's behind a standoff. So having done that, same procedure, raise the clips, drop the bracket against the right sidewall, snap the clips in place, and I re-land these 2 connectors on the back plane board. At this point, I can remove this cover plate over the field terminal board, which is really just here to protect against anything falling down into the components, creating a short circuit. Now I can proceed to terminate all the wires from the wiring harness into their correctly associated places along TB2 and TB3. TB1's the power here, this cable. Then we'll reinstall this cover plate after that. Once we've reinstalled the cover plate onto the field terminal board with the screws that were supplied with the kit, we can proceed to terminate the customer's wires along the terminal blocks on the DIN rail here. Once we've done that, we can close the door to the explosion-proof box, bolt it down, re-energize the electronics. At that point, the next step will be to connect by Ethernet to this electronics with a laptop. We can do that in one of 2 possible ways. We can use a patch cable here from this RJ45 jack on the field terminal board. At that point, you might want to leave the cover plate off until you're finished with that. The issue with that is that requires you to leave the box open. Another possibility is that you use what's called a VDSL system. With that system, if you don't have any Cat5 or Cat6 cable pulled into your conduit, which you probably did not have with the Series 3 or Series 4 meters because there was no Ethernet connectivity with that hardware, then we have an option that may provide a good solution for that, which is to use a VDSL system. That requires this external VDSL modem as well as the internal VDSL modem that lives behind the field terminal board inside of this enclosure. Between these two devices, we can use just ordinary 2 conductor wires, twisted, shielded, unshielded, doesn't matter. We bring that cable into here, we power this box up. This box lives in a safe area where you want to run the laptop with Sonic Explorer. It needs some power, 24 volts DC. You can get that from your bus, or you can use a simple wall wart type power adapter to power this box up. Here we have an RJ45 jack that we get our Ethernet. We can go by patch cable to our laptop at that point. And from there, we'll proceed to program the electronics up with the parameter setup that we have provided you based on the information you supplied to us about the meter that you want this electronics to work with. That's pretty much the whole procedure, and thanks for watching.